Okay, so hi everybody. My name is Tianzi Yang. I am one of your fellow classmates. I'm also known as the only physics kid in the forensic science program or the only forensic science student in the physics program. So I'm here to present my masterpiece under the microscope. It's called The Everlasting Mystery. Just bear with me. My English is going to be crumble because I haven't been speaking English for a week. So yeah. So let's start with my showcase. So this is my masterpiece, or I should say it the masterpieces. This is actually 3 pictures that I put together. So take a guess. Oh, by the way, if you guess that these 3 pictures are some weird planets that's outside Earth, good guess, but this is a microscopy class. But I'm sure you can find your spot in our astrophysics program. Let's reveal it now. This is actually my necklace, my amber necklace, the one that I wear all the time. Um, what exactly is an amber? Amber is a type of resin. So when you make a cut on the tree, like a surface of a pine tree, there's gonna be this sticky liquid gonna come out of the surface of the surface of the tree, and that is the resin, the resin. It is a mixture of organic compounds. Once it dries down, becomes a solid, that becomes the amber. More importantly for us, this type of material is also birefringent. So now the question comes down to why I'm calling this a everlasting mystery. Let's go back to the showcase right now. This is the 3rd picture of the showcase. I presume you remember. You can see the circle right here. Just look very carefully in there. It kind of looks like a small insect that is trapped in the amber, right? So, I mean, this could be the head. Oops. And this could be the leg, right? So it could be insect. With this question bear in mind, let's talk about how I get this picture first and what type of microscope I used. So the type of microscope I used is the stereomicroscope. It is the not the exact one on the left, not this one. I don't believe this is the exact same model we used, but it's extremely similar. It both come from the company Nikon. I forgot to take a picture of the one that we used, but it's the one that we use for glass fragments and fibers, also the paint chip of the car, of the vehicle. So that's the one. It has 2 eyepieces. One of them is right here, the other is right here. And the two of the 2 sets of the knots. One is here, the bigger one, that is for changing the working distance more in a larger scale, and also you have a fine adjusting knot. And right here, I don't know if you can see it, this is just the LED. So a quick recap on what exactly is a stereomicroscope. On your left is a ray diagram of the stereomicroscope. It comes from right here. This is where the specimen would be locating on. All the way, the light rays goes up, and then go to your eyepieces, the 2 eyepieces right here. Ignore the CCD, we don't have that in this case. So again, this is a stereomicroscope. It's very similar to a compound microscope. However, it uses the reflected light to conduct an image. In a standard compound microscope, most of the time you will have transmitted light. For this case, the reflected light is powered by the LED underneath. It means that the object used in stereomicroscope does not have to be a very thin translucent pieces, which is perfect for this case because the necklace is thick, it's not translucent, so we can use the stereomicroscope. It has a zooming system as well. The zooming system right here is from here to here. The zoom system is just multiple lenses combined together. You will have a virtual, it will form a virtual image on one of the lenses here, and then you zoom on that, zoom again, zoom again, zoom again through the different lenses, and essentially you will have what's the final image into your eyepieces. Also, it has two eyepieces as well. We just mentioned it in the previous picture. The reflected light goes through the primary object lens is this one. Here, it shouldn't be a dashed line, is the entire thing. The light go through here, and then it's gonna separate into two. It's not separating here, it's actually here. It's gonna separate into two beams of light, and then it goes through a parallel tunnel, this one and this one separately, and then goes into the eyepieces. So one could argue that a stereomicroscope is just a fancy version of a compound microscope. Let's just recap on the comparison between a stereomicroscope and a compound microscope. The stereomicroscope has a greater working distance and then a greater depth of field. Also, it's going to have a larger field of view. That means you will have a larger picture. Also, the picture you acquired is going to be 3D as well. This is what I mean by 3D. Just look at this. Look at these two pictures. On the left is the second one. On the right is the third picture that I took. Here you couldn't see any of the cracks because it's more focused on the inside of the amber. But on here, especially right here, you can see the cracks. That is because it's focusing on the surface of the amber. So basically, it's like there's different focal point that it can focus on. Once we are focusing on the very surface of the amber, you will see the cracks, and here you couldn't see it. That's basically how it works. So here is the setting of the stereomicroscope. In total, the magnification is 40. There is 10 on the eyepiece and then 4 on the objective lenses. So now the question is, why I choose the stereomicroscope? Well, we do have the other options. There is the confocal microscope, there is the SEM, there is also the PLM. Well, let's just see them one by one. The confocal microscope, well, it does sound like a good idea initially for me, since we really want to see the bottom of the layers, like the similar experiment we did for the cartridges. We want to see the bottom layer. The problem is the amber is not transparent enough for the laser to actually go through the that thickness of the amber and then focusing and scanning on the part that we want. I actually consulted Dan about this. Dan is one of the person who in charge of the physics lab, and then he's also the person who fixed the confocal microscope at the beginning of the semester. And he said, no, it's not gonna work. So basically that means out of luck with the confocal microscope, what we left is the SEM and then the PLM. Well, the problem with the SEM is basically I can't really place the object on the actual little stamp. If you remember, the SEM is the one we use for GSR. I can't really do that. It's just not gonna be fit on a stamp. It's not gonna be able to fit into the vacuum chamber. Also, the purpose for me is not to analyze what exactly is the chemical composition of the amber. I just want to see what's inside. For the PLM, it does work because remember, the amber is birefringent. But also, it is really not my purpose to find out like what exactly is like if this is a birefringent material or not. That's not the purposes. The purpose is to find what exactly is inside this amber, if that's an actual bug trap inside. So basically, that's why I'm calling it a everlasting mystery, since I couldn't really find a way to find out that if there is an actual bug trapped inside, or is just my illusion come from staring at the microscope for 2 entire hours. I did ask my mom, who basically gave this necklace to me, and she has no clue as well. She asked her mom, my grandma, if there's a bug trapped inside there, if she knows anything about it. My grandma said no as well. So basically, there is not a non-destructive method for now to find out. Or using Dr. Woodell's word, if I really crack this amber and see what's trapped inside, this experiment would not be reproductive. So for now, it's just gonna remain a mystery. This is the end of my presentation. Thank you very much for listening. Stay home, be well, and I hope I'll see you guys very soon next semester, or even we can go back to school anytime soon.